So regarding development, even today, when we have AI for doing things, the most crucial part of entire software is end-to-end tests. When you define the entire flows of your user, how exactly user, um, how exactly user communicates with your program. So for example, right now I'm building my own shell using Kotlin, so the user can input such a command, and here's the output of my program. Again, user input, the output from the program, user, and so on and so forth. So all of these here on this CodeCrafters platform, they present with such a requirements given to you. So in the real, on the job, you probably will encounter also such kind of tickets. Maybe they will come with predefined like requirements, maybe under specified, meaning that you should go and ask for additional requirements to clarify the requirements, to add something or remove, or something is ambiguous or duplicative, or something is not in consistent state. So you refine, and you will have kind of tickets that probably will mimic something like from this platform, Codecrafters. So yeah, and I, as a human, I just forget to do test-driven development. So what I do is that, for example, here I go, and to implement a new stage, I copy the entire requirement and go to LLM, to ChatGPT or Gemini or whatever uh, LLM exists, and just paste, and also paste all of the code within my project. So I have this beautiful, simple Python script to copy all of the code, all of the Kotlin files to clipboard, and then when it's ready, I passed it to ChatGPT, for example, with the new requirement. And what ChatGPT outputs is the code that I need to modify or add or delete somewhere, basically to alter the code. And then I just commit and push. And here on this platform, they implemented automated tests that auto verify everything if the code is passes their tests. But their tests But the problem with such an approach is that they probably do not cover every scenario. What it means is that so the tests within this Codecrafters platform does not cover all of the requirements, and AI somehow it can modify the parts that do not intended to be modified. So besides introducing a new feature, there is a chance of breaking existing features. So this is something to avoid in real production development. And what I see, the only the only tool or the only instrument to prevent such a disaster as breaking already established features is to implement integration and end-to-end tests. So those tests must run throughout all of your program, and they should the ideal end-to-end test this should be external to your program, that is maybe implemented in another application that just builds when your application is built, it just gets for example, the jar. For example, in my case, this is the simple CLI application. So it gets the jar and then supplies different arguments to this jar, to the Java or Kotlin or Spring-based application, and determines the output. What's the output? So this is the only tool today that is deterministic and see exactly what was added, what was wrong. So without end-to-end tests, your project is in a big trouble. And today at my job right now, so I did not communicate it thoroughly to my employer that I only want to participate in the projects with established culture of end-to-end testing. What we have right now is developers introduce a new feature to the code base and they break existing features. Some null pointers exceptions are a lot of null pointers exceptions, and so on and so forth. So yeah, and we only have unit tests. We have some coverage of unit tests on my day-to-day work, but it is not enough to have unit tests, because unit tests, for example, as I have here, for example, here in command parser test, it tests only one component. command parser in this case. This is the component that is being tested by this unit test. But it only can catch the current state of this component. It does not catch the state of entire system. That's why those unit tests, they do not capture the inter-component communication, which, so components, we compose component to build an entire system. And it's hard for us as a, for example, LLMs or people to catch and track every connection between components to capture how the data flows within, like, throughout all of the scenarios. This is probably not something achievable in the near future. Maybe LLMs can progress, of course, but probably they can at some point to extend this probability that they output quality. But 100% deterministic system that will capture everything is end-to-end test. That's why, so the point of this is, without end-to-end tests I was developing, and I were in a big trouble even in such a small project in my pet project. Even on the pet project, I think this end-to-end test is like a driver for development. This is not something optional that we can implement or cannot implement. I think that this is like the most crucial. So this is the first-class citizen. This should be the first-class citizen within your project, I think. And the code, the actual code that is run in production, this is just a derivative of end-to-end tests. So it's not really. So the first priority is end-to-end tests, and the second priority is your architecture. People often talk regarding architecture, solid composable design principles, something clean architecture, how to keep business logic isolated from database, so on and so forth. But if you imagine the pyramid, this is should be given less priority than end-to-end test. Fully established, clean end-to-end test that extendable. For example, here you can see that my end-to-end tests are extendable because I have only one function that is reused, and new test cases, they are just added like that. So I reuse the already established functionality. So this is really convenient. And suppose your application becomes, maybe a customer wants to, so probably you prototyped your application using Kotlin, but Kotlin and JVM is not really for system level programming. They are for Java, and Kotlin are for application level when you have enterprises or some e-commerce systems where you need to rapidly develop your product. But if we talk regarding the shell implementation, Golang and Rust or Zeek are better options for system level programming. So when, for example, as I see right now, I should not probably give the priority regarding how to organize the actual code, the doing things, because at some point I can throw away entire my project, my Kotlin Spring-based project, just throw away each and every file, but leave only end-to-end tests, because they show the reality. They exactly show how the system should perform in all the scenarios that we can imagine from the user. And then what I will do is just leave these integrational tests. I will probably somehow change this function to run, for example, I will throw away each and every file and then just ask LLM to rewrite everything using Rust. But LLMs, they have no deterministic behavior. Only end-to-end tests have determinism. And what I will do is I let all of these files be rewritten to Rust, and then run my integration or end-to-end tests against new implemented solution. That's why, like, on migrating to another language, those end-to-end tests will show the reality. Maybe some human or LLM during migration, they will have some errors in implementation because, as I said, people and LLMs today, they do not have determinism. So that's why. So this is just my thinking process regarding the roles. What developers should focus and engineers should focus more, I think. So the point of this is that first priority is number one priority is end-to-end tests, automation tests, not manual tests, because yeah, this is another topic, but I think this is logically to say that only automated tests make sense to have within your project. So that's basically it. Thanks for watching.